Today's lesson is on defining the derivative of a function and using derivative notation. So let's start with the notation. If I have a function, f of x, the derivative is also a function, and it is like this, f prime of x. So that is how we notate a derivative. Now, if we have y, so if we've got like y equals, we've got this equation, the derivative could be this, but usually what we'll do is dy over dx. Now, you're going to see this year, you're going to see sometimes d over dx and sometimes dy over dx. So the difference between these two notations is this is a verb, this is a noun. So the first one, if I say of d over dx, x squared plus 3x, this is telling you to take the derivative, do something, find the derivative. A noun, this would be saying that the derivative is this. So just kind of be careful with your notation this year. Do something is something. Okay, and then now the definition of a derivative. This is what we have been working on so far this unit. So we've got this f prime of x. It is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. That right there is the definition of a derivative. Throughout this unit, we're going to learn and memorize all these different shortcuts and properties of how to take derivatives quickly. But lucky you, in this lesson, we're going to use the fun definition to find our derivatives. Okay, so starting out, we are just going to kind of interpret what a derivative is in an equation, a graph, some application. So first, I'm just going to sketch a graph. It is nothing specific, just I have a curve. And let's say I have f of negative 2. F of negative 2 just means at negative 2, I've got this value. Okay, so what does the derivative at negative 2 mean? The derivative is the slope of a tangent line, at that point. Now, derivative, if I have, so that was at a single point. If I just have the derivative of the function, I can use this function to find the slope for any point on the original function. Okay, so if you're given an equation, so let's just say we have f of x equals 3x squared plus 1, and let's say the derivative of f of x is 6x. So if you're asked to find f of 3, let's say f of 3 equals 28. What that is the point on a function. That's the position 3, 28. If we have the derivative of 3, let's say that equals 18. That is the slope of the curve, slope of the tangent at that point. So slope at 328 is 18. Okay, and then application, something just real simple. Let's look at the distance d to run a marathon. And that's measured in miles. And so the distance in miles over t minutes. So if I have d of t, that is the distance, the position after t minutes. distance after t minutes. If I have the derivative, that is telling the speed at t minutes. Okay, so there is kind of the using and interpreting the derivative. And now we're going to use that limit definition of a derivative to find the derivative. So we've been kind of practicing this when we're finding the slope at a single point, but now we're finding the derivative, which is the function that helps you find the slope at any point. So let's say I have this function. Y equals 3x squared plus 5x plus 2. I want to find the derivative. Dy over dx is equal to, so I'm going to do this by using the limit definition. So I'm going to just write that out first. Limit as h approaches 0, f of x plus h minus f of x all over h. Okay, so let's use this function now. We're going to plug in that x plus h in for x, and then we just have our f of x. So limit as h approaches 0 of, I'm going to put this in brackets here, so 3x plus h squared plus 5 times x plus h plus 2. So that, what I just did, is right here. And now I'm subtracting f of x. F of x is 3x squared plus 5x plus 2. And that is all over h. Okay, so let's simplify in here a little bit. So I still have limit as h approaches 0, 3 times, that's x squared plus 2xh plus h squared plus distributing 5x plus 5h plus 2. And then I will subtract. Actually, I'm going to get rid of this bracket here. So I'm going to just distribute that subtraction sign. So minus 3x squared minus 5x minus 2, all of that, over h. Okay, so now I still need to distribute this throughout. So limit as h approaches 0, 3x squared plus 6xh plus 3h squared plus 5x plus 5h plus 2 minus 3x squared minus 5x minus 2. That's a lot all over h. Now the fun part, find things to cancel. Let's see what can cancel. I have 3x squared minus 3x squared. I've got 5x minus 5x, 2 minus 2. I think that's it. So limit as h approaches 0. I'm going to put the top numerator in standard form. So I've got 3h squared plus 6xh plus 5h over h. Factor that h out. So h, 3h plus 6x plus 5 all over h. My h's cancel, and I can plug in 0 for h. So 3 times 0 plus 6x plus 5 is 6x plus 5. Whew. Okay, we did all of that. All All right, what did we just do? 6x plus 5. Let's go back up here. I've got y is this, and my dy over dx is 6x plus 5. What I have is this right here, the derivative, is a function. This function can tell me the instantaneous rate of change of this function at any given point. Last part of the video, I'm going to give you a derivative, a function and its derivative, so you don't have to find it. But what we're going to do is write an equation of a tangent line at a point. So let's say I have f of x equals the function 5 times the square root of 3x plus 1. Now I'm going to give you the derivative. The derivative is 15 over 2 square root 3x plus 1. And what we want to do is write an equation of the tangent line at x equals 5. Okay, so how do we write an equation of a tangent line? A tangent line is like a linear function, and we can use point slope form. Y minus y1 equals m times x minus x1. But how do we get all of our numbers? Well, a single point, so your x1, y1, comes from, here's your x1 right here. We're going to plug that in to f of x to find y. So I've got 5 comma, all right, plug in 5. 3 times 5 is 15, plus 1 is 16. The square root of 16 is 4, times 5 is 20. So there I have a point on the tangent line on f of x. And now I need the slope. Well, how do you find slope? It's the derivative. So we just have to plug in 5 into our derivative, and it gives us our slope. So plug in 5 here. 3 times 5 is 15, plus 1 is 16, square root of 16 is 4, and 2 times 4 is 8, so our slope is 15/8. So if I'm going to write an equation, I've got y minus 20 equals 15/8 times x minus 5. This is the equation of the line tangent to this function at this value. There is your full lesson today, your full video, so good luck with your assignment.